7.3 Wheels, Pulleys, and Blocks from Science Connect 1, page 140 to 144. A pulley is just a grooved wheel. With a rope threaded, though, it becomes a simple machine. The load is attached to one end of the rope and the effort is applied at another. So you can see here we have a pulley. It's a circular wheel attached to something that would typically hang maybe or move. The pulley is grooved so that a rope can fit within. And again, the load would be attached to one end and the effort would be on another. In this case, we'd probably be pulling down on our rope and hoping that the load would move up. When a load and effort just support one another, the system is in equilibrium. So what that's saying is that if we had a pulley and a rope hanging off of it, I'm the best drawer, obviously, and we have some mass here, and we are pulling on the rope just enough that the mass is stationary. Okay, so it's above the ground. And again, we're holding the rope so that it is not moving. Okay. We have a system in equilibrium. All right. There are a couple different types of pulleys. There is a single pulley, and it's used to change the direction of effort. So if we have our load here, our single pulley allows us to pull downwards where our load moves upwards. Okay. The wheel is attached to the surface, usually up high. It changes the direction of the applied force, and there is no mechanical advantage. The same amount of force is required. So to lift the box upwards in our arms versus pulling the box downwards using this pulley, it is the same. Fixed pulley is what we were looking at here. So a fixed single pulley. A movable pulley, the pulley moves with the load. So the rope is attached and the load is attached to the pulley. We pull up typically on this one and we will see our load move up. The wheel supports the load. And again, the effort is in the same direction as the movement. So we are moving the rope upwards and the load will move upwards. It reduces the forces needed to move an object. So in this case, we need the same force as if we were to just typically lift that. When we add the pulley onto the rope itself, we reduce the force required. Is a crane considered a fixed or a movable pulley? Well, when we let out the rope moves along this pulley. This pulley is attached to a hook and our load would be attached below. So because there's a pulley within this system and the rope is moving through the pulley where the load is attached to it, a crane, or this one in particular, is a movable. What happens as you compound pulleys? So if I attach two pulleys, maybe one to the roof like I've got here and one to the load, okay, so we have a fixed and a movable pulley, it gets easier to lift our load. It reduces the effort required. So a combined or a double pulley has at least two pulley wheels. You can have more. The more complex the pulley, the more effort needed to move the object decreases. AKA, the more pulleys we have, the less effort we need. Okay, let's write that out. More pulleys equals less effort. A wheel and axle is another simple machine. Seems a little bit simple, but a wheel, something with a large diameter, turns something with a small diameter, the rod or axle. So examples are a doorknob. The doorknob itself is a larger diameter than the system within. If you were to actually remove the doorknob and just try to turn the rod or the axle, it would be very, very difficult to open the door. A screwdriver acts as a wheel and axle. The screwdriver handle acts as a wheel, so it is a larger diameter than the screw, the axle. A nut and bolt and wrench. So if we have a nut or a bolt and we attach a wrench to it, oh man, my beautiful drawing. The bolt is spinning in its threads and it acts as the axle or rod. And because our wrench has a larger diameter or radius, it acts as the wheel. A winch itself also acts as a wheel and axle. Where we are winding our rope is the axle. The wheel is what is turning. If you were doing it by hand, of course, the wheel would be larger than the axle. We don't just try and spin the dowel here. We would add a handle with some extension, and that makes it easier to turn. What would happen if you exchanged a door handle? So one you would normally have on the doors in your house, for a small knob, something like one you would find on a drawer in your home. Would this make it easier or harder to open the door? By reducing the size of the wheel, okay, we are keeping the axle the same size, the rod connecting through to the other side of the handle. By reducing the radius and diameter of the wheel, we have made this harder. Okay, turning a small knob versus turning a large knob is a more difficult task. A few practice questions, number 1, 2, 3, 4, and 5 on page 144 of your textbook to help understand these ideas a little bit more.